we got Lawton and Adish joining us today. And I actually received confirmation, not only can my wife hear me from the other room, our neighbors can too. So I told you, I'm excited about this. How could I not be? This is really
I'm excited to be here.
All right, so I won't introduce themselves. I'll let them do it because they could do it better. And all I know is that there's an awesome plushie behind Lawton. Anyway, who are you? What do you do? And what value do you bring to the table at today's show?
Adish, I'll let you take it away first.
Thanks. Hello, everyone, to all our viewers of AWS OnAir. My name is Adish Pobe. I'm a product manager here at AWS. I've been here for just over 5 years, primarily working in the security space. I really enjoy the space. We have seen a lot of products launch over the last couple of years that have made a lot of difference to our customers. And I'm really excited to talk about a new launch here, DNS Firewall Advanced. I think it's the next iteration of DNS Firewall that our customers have been asking for. So excited to talk about that.
Awesome. And Lawton, off to you.
Awesome. So yeah, my name is Lawton Pittenger. I'm a security specialist solutions architect here at AWS. I focus mainly on our network and application protection services. So you can basically think all of AWS firewall services, and I'll be leading the demo portion of today's call. So happy to demo the new feature today.
Nice. So Kyle started giving us a little bit of an intro here, but I wanted to just keep it really simple to begin with. You know, if you listen to popular tech jokes, you will know that DNS is often
always DNS.
Yeah,
Always DNS.
Every problem that you've ever experienced is always DNS. That's a very popular tech joke. But can we give just a quick kind of summary of where DNS sits in the stack and what it's used for across networking before we jump into what we're doing with a firewall around it?
Yeah, absolutely. I think DNS has been probably one of the most exploited ways to send or exfiltrate data from customers. This process is typically called DNS exfiltration, where you typically have a bad actor that compromises an application, could be in your VPC, and then uses DNS lookups to send out data to that domain that's hosted by the bad actor. And that's where product like DNS Firewall that we launched a few years ago comes into the picture, where you can really create rules and policies to filter and regulate any outbound DNS traffic to these bad domains. Happy to talk a little bit more, but DNS Firewall Advanced is really taking that to the next level by helping you stop more advanced threats like domain generation algorithms or DNS tunneling that can't typically be surfaced using threat intelligence. You need more advanced capabilities to stop those threats.
And for those that might not be familiar with the terminology of DNS, when you type in Amazon.com, that is, you're typing in a fully qualified domain. Maybe, I don't know, keep me honest here, folks. But when you type in that name, things and magic are happening in the background to resolve that to almost like a street address, to an IP address to where that should go. Sometimes It could also go to like another alias, kind of like a forward address for the mail station. Jeez. Oh my gosh, right.
Post office? But you're right. You're right on, Kyle. Amazon.com, that's the human version of where you want to visit, right? And then there's behind the scenes, all of the server side computer version of how do I get to that, from Amazon.com, me as the human, how do I get to it, in terms of all the networking infrastructure, all the servers that are running, the IP addresses. And DNS has famously been one of the protocols used. And it propagates, right? Like that's a very common term that you hear when people talk DNS. It propagates out like all of this information about where to find the thing that serves up Amazon.com for you when you type it into your browser.
Yeah. And so when we're talking about DNS firewall, this isn't something that you need to spin up a new appliance, right? Because Route 53 resolver is being used even when you have just resources using the default configuration settings of a VPC or a virtual private cloud to connect to the internet or communicate to the interwebs.
Yeah, you're absolutely right. Route resolver comes by default to all VPCs. It's being used by customers today. If you want additional security for traffic going out from your router resolver to any domains, that's where DNS firewall comes into the picture, where you can opt in to create rules to either block bad domains that you know of, or you can create a more walled garden approach to say, I only want to allow access to these specific domains, everything else gets blocked. So you have these options that come with DNS firewall today. So it gives you a holistic approach to blocking.
Yeah, and so we had DNS firewall, and it's been around for a hot minute. It's been around for years, right?
Yeah.
Now, what is now the future state with this new feature that was announced and that we're going to be walking through that kind of changes the game for DNS firewall?
Yeah, that's the perfect segue into DNS Firewall Advanced. So over the years, as you know, bad actors have become more sophisticated, they've been using or leveraging new tactics to really create attack mechanisms. The most common way to do that is DNS tunneling, where an attacker has already, they already have a malware or a botnet sitting on an application or instance, and that's phoning home, to a bad domain somewhere that is hosted by the bad actor. So the data is getting exfiltrated over from your application over to the bad actor over DNS, and maybe the customer is not even aware of that. This gets even more advanced when attackers start using domain generation algorithms. Now, for those who don't know, domain generation algorithms is where a bad actor creates hundreds or thousands or sometimes even millions of domains that they just run through for exfiltrating data. So it becomes much harder for your typical threat intelligence feeds to really track that, and they alone can't really block these bad domains.
You end up almost playing like a game of whack-a-mole where you're trying to address, all the, believe it or not, those that want to do harm to like infrastructure, like cybersecurity stuff, they scale stuff out too. Speaking of scaling, well-architected a framework for resiliency, scale your stuff. Anyway, they want to be resilient, but they also want to make it harder for those that are looking at the bits, bytes, and bobs to trace their activity. And so they're scaling to hundreds to thousands, dare I say millions of domains. But there seems to be a way that we can address this, because instead of trying to look at it by the domain and maybe the reputation of a domain, how could we, work back from that and say, like, you know what, instead of tracking the domains and the reputation, big reputation.
Hey, Kyle.
What?
I want to look at some bits and bytes and bobs. Can we ask Lawton to pull this up while we continue talking about kind of the theory? I like to see it though.
Time out. We are about to do a demo.
That's true.
Without the demo dance.
We weren't adequately,
you know what happened last time? You and I hosted and we didn't do a demo dance.
Yeah, I don't like to think about it.
Well, all right. So let's do the demo dance. All right. 1 and a 2 and a demo dance complete. Now let's bring up Lawton's screen.
Awesome. So in the demo today, we're just going to demo an actual DNS tunneling example. So on the left here, we have what's simulating as like a compromised server, where we'll install a C2 implant and basically establish command and control server connection with this command and control server. So to get started, just going to fire up and show that as of right now, there's currently no connections. And for the C2 portion of the demo today, we're going to be using Sliver, which is an open source command and control server framework. And we're going to be doing this, command and control interactions over the DNS protocol. So first, we can just see that, there's no beacons or no sessions, do not have any sort of, C2 connectivity. So let's go ahead and fix that. And what we're simulating today is essentially a software supply chain attack. Say you're installing software from a third party or some type of open source software, and that's been compromised. And when you think, you might be installing your legitimate software update from softwareupdate.com, you're actually might be installing a C2 implant and executing that C2 implant. So that's what we're going to be.
And one thing I do want to mention to the audience, Lon did a lot of footwork to get this to work. It's not that it's this simple, okay?
Exactly.
But to demonstrate, what DNS Firewall Advanced does. Lon has been burning cycles to get this. So it's easy because this is a baking show, right?
Yep.
But for those unauthorized users, it's not as easy as.
Correct. And I saw one question about the integration of network firewall with DNS firewall. So the way that kind of differs is, your DNS requests are actually going to go to the Route 53 resolver. So they're actually not going to pass through your network firewall. So these DNS requests are not going to be seen by network firewall. So that's where you would need something like DNS firewall to get visibility into this attack surface as well.
Thanks for addressing that question, because I was going to bring that up. Bottom's on it.
Yeah, we hear that from customers all the time. Oh, I'm already using network firewall, or I'm already using WAF. Why do I need DNS firewall? So that's kind of how they all fit together. So as you can see now, since we updated our software, so to say, we actually installed the C2 implant and executed that implant. So if we jump back over to the Sliver server, we can see that we now have a beacon that is beaconing out. And we can see that that is over the DNS protocol. So let's just go ahead and use that beacon to try and run some commands. Just a basic
real shampoo.
And for those who might not be super familiar with C2 servers, a beacon is essentially just this server is going to beacon out to the command and control server. It's set to beacon out every 5 seconds. So when I issue one of these commands, it essentially just adds it to the queue, and every 5 seconds it'll execute that command. So as we can see here, we've got back that we are in the temp directory, and let's say on this server we have some credentials, which you shouldn't have credentials stored on your server, but let's just say, we're storing database creds on this server.
I see your password.
So on the Sliver side, we can actually see this as well too. Oh, there's the creds via the C2. So this is just
bad. Bad.
So this is just a super basic, DNS C2 example. So let's just get into how we would actually block this with DNS Firewall Advanced. So I'm going to jump over to the DNS Firewall Advanced console.
And AWS console. Love to see it.
And right here, we just have an empty DNS Firewall rule group. So we're going to add some DNS Firewall Advanced rules. Is this too zoomed in? Should I go ahead and, is that better?
I don't know, Chad. What do you think? I think that it looks great.
Okay. So first rule I'm going to put is just to block DNS tunneling. And we're going to set the confidence to high. So I'll explain a bit what this means in a second. So traditionally, before DNS Firewall Advanced, you just had these domain lists that you could choose from. Now with DNS Firewall Advanced, you have this other option to enable the DNS Firewall Advanced protections. So for this use case, we're going to be selecting DNS tunneling. As Adish mentioned, there's also, DGA options as well. And essentially, you configure a confidence threshold. So this is basically how confident the model on the back end is that this is either a DNS tunneling threat or a DGA threat. It comes in high, medium, or low. So high is, going to be only the most certain and well corroborated threats. Medium is going to be kind of a balance between high and low. Detects a reasonable number of threats while maintaining a manageable level of false positives. And low is going to catch a lot more. It's going to increase the detection rate, but it'll catch more potential threats. So what we're going to do in the demo today is we're just going to set it to block on high threats, or threats with a confidence threshold of high, and we're going to set it to just alert for anything with a confidence threshold of low.
And the reason why we're looking at confidence thresholds is because this is based on behavior, right? This isn't like you're establishing a baseline of behavior for then the confidence levels to affect, change, or block traffic, right? That's why it's not like
legitimate traffic goes over
That's right.
DNS all the time, right? So you have to figure out which is not so legitimate, right?
Correct. Yeah.
Correct.
So I'm going to put in the rule here for DGA now. It's going to be essentially the same thing. Just select DGA instead of DNS tunneling.
And one thing I think is great to note too is that I saw that there's two actions. There's alert and then there's block. So if you're wanting to bring this in and you're trialing it out or testing it out, you can set it to alert without potentially impacting, and just understand what's happening in your environment. So you could say, hey, one, this is potential funny business that's going on, so you can investigate it. Or then you can eventually switch the bits and bobs and bytes to block the traffic.
Yeah, you're absolutely right, Kyle. This is, and I think Lawton, you're showing that, but a lot of customers actually do that, where they put all the low threshold rules in alert mode. And then we have later in the demo, we'll also see Security Hub come into the picture where you can view all these findings and can take actions. So you're not blocking anything that could potentially hamper your availability.
All right.
So I just created the rules, and now we have to associate this rule group to our VPC. And as you can see, this may take a few minutes. So while this is, applying out to our VPC, I already have a sample log from running this demo yesterday. So we're just going to shift over to that for the sake of time.
Through the art of television magic.
Exactly.
Is it television? We're on TV.
So when DNS Firewall Advanced actually blocks one of these, DNS tunneling attacks, this is a sample log entry that it will generate. So as you can see here, the query name, this was the DNS name that it was essentially using for DNS tunneling. We've got a very not obvious domain called dnstunnel.com. Typically in the real world, it wouldn't be this obvious, but as you can see, it's appending a very long kind of encoded subdomains on these. And this is how it actually gets the information across using the DNS protocol. DNS is kind of a question and answer system. So it uses that to essentially exfiltrate data. And we can see down here at the bottom that the firewall rule action was block and that the firewall section was DNS tunneling. So for alert, if you were to configure this in alert, it would be a similar type of log. You would see that it caught something. You could see the EC2 instance ID here as well too. So you could know, hey, something's probably going on with this EC2 instance. Let's go investigate. And as Adish mentioned as well too, they recently just launched integration with Security Hub. So you can also see DNS firewall findings within Security Hub via the integrations. So if you go to Security Hub and to integrations and just search for DNS, you can see, zoom out again too, just because I'm on the tiny laptop screen. You can see that it's currently accepting findings from DNS firewall for the AWS lists or any custom domain lists. Haven't configured that, but it's as simple as this. You just click accept findings and it'll start accepting those findings. And for DNS Firewall Advanced as well. So let's just take a look at what this finding would look like within.
And then while that's loading, Security Hub is a service that centralizes the different security findings that the different security services within AWS can generate. So you have this comprehensive view. That's the Security Hub pitch to those that have not been familiar with Security Hub until now.
Yep. Thanks for that added context. That definitely helps. So the findings will appear here, and you can see the severity is critical because we are actually blocking, DNS tunneling. So that indicates that there's some type of, malware or C2 implant on that server, and that you're going to want to go investigate it. So if you click into the finding as well too, you could investigate with Amazon Detective to dive deeper and, put together some more threats. And you can actually see, the product name was Route 53. So this was blocked by DNS Firewall Advanced. If you scroll down, you can see the EC2 instance ID so that, if your SOC team is reviewing through Security Hub logs, they could see this, they could check out the EC2 instance ID, go investigate the instance, perform, further investigation on that. So with that being said,
these findings appear by default, so you don't have to switch anything on our Security Hub side.
Love it.
Correct. Yep. So if we go back over to the Sliver server, if our thing has propagated, which looks like it has, and if we run beacons again, we can see that it has missed its check-in. So that red means it is missing its check-in. So it's supposed to be beaconing out, but it is no longer. So we
can you hear me?
So we can see that the C2 implant has been killed with just a basic DNS Firewall Advanced rule.
Awesome.
We got about 1 minute left. This has been incredibly informative, and it's very, for me, it's like a person who doesn't work security, 24/7 as part of their job. It's always incredible to me to see the attack patterns that people come up with. Let's shove a bunch of stuff through DNS protocol, right? Let's see what'll get through. It's incredible. And then the people who are guarding you have to come up with plans to mitigate that. So very cool to see all this come together. Very, interesting to see, how you all are thinking to help people. Speaking of helping people, do you have any final recommendations on what they should
any ways that you could get hands-on on this?
Yes, I do actually. So we actually host what's called activation days, where we kind of go through the security services and provide prescriptive guidance to achieve outcomes when using AWS. We go through overviews of the services. We dive deep with hands-on labs into the services. You can actually get hands-on experience with this exact C2 demo that I just showed on today's call in the network firewall and DNS firewall activation days. We have this deployed in the workshop with like step-by-step instructions of how to use the implant, how to block it with both network firewall first, and then it fails over to using DNS. So you can block it on both the firewall services. So yeah, check out the activation days. We'll be sure to drop a link to these. They're free events. Just go ahead and register. We have one upcoming next week.
Awesome.
And the week after that as well. So yeah, definitely check
Great.
them.
Well, thanks to this dynamic duo, now we got to introduce our next favorite dynamic duo coming up with Repost.